Timers, one of the most used PLC features in real machines. Remember that basic start-stop logic we built in episode 2? It is time to make it smarter. By the end of this video, you will be able to add delay starts and safety stops using IEC 61131-3 standard timers. The timer function blocks in the OpenPLC editor can be accessed from the standard function blocks library. They are TP for pulse timer, TON for timer on delay, and TOF for timer off delay. In IEC 61131-3, time isn't a clock, it is a duration. It is stored in milliseconds and written using the T-hash format, where the units are as shown. Thus, we can set time as, or keep it simple like, or. The timer blocks use this to measure delays and control when outputs turn on or off. Let us add a new row with the timer on delay, a button 1 contact at the timer input, and the LED coil at its output. The on delay timer delays setting its output to true for a preset period after the input becomes true. The PT input is the preset time, which we will set to 10 seconds, and ET is the elapsed time, which increases from 0 up to the preset time. Now start the simulator to see how the on delay timer functions. Force the contact to be true and observe that ET increases from 0 until it equals the preset time, at which point the timer output Q turns true. When the force is released from the contact, the output turns false. Now, when the contact is forced through to start the timer, and the force is released before the elapsed time equals the preset time, the timer is reset to 0, and the output coil will remain false. The off-delay timer is much like the on-delay timer, except it delays the turning off of its output. Let's replace the on-delay timer with it. Set the time to 10 seconds and start the simulator. Now, when the contact is forced through, the output is immediately set to true. When the force is released, the timer output is delayed for the set time before the coil becomes false. The pulse timer generates an output pulse for a specified duration when its input is enabled. Let us replace the off-delay timer with a pulse timer and set the preset time to 10 seconds. When the logic is uploaded to the ESP32 and the button is pressed, the LED turns on and remains on for the specified time, even after the button is released, then goes off. Now, to put all this together in a real application, place the on-delay timer, SRO block, and off-delay timer between the pulse timer and the coil. Set the timer's preset time to 5 seconds and assign button 2 to the arrow input of the SRO block. Then upload the logic to the ESP32. When button 1 is momentarily pressed, the LED is delayed for 5 seconds before coming on. And when button 2 is pressed, the LED is delayed for 5 seconds before going off. Thanks for watching. Timers and counters are the big two of industrial logic. You've got timers down. Counter is coming in the next episode. So hit subscribe, leave a comment, and give a thumbs up. See you in the next one.